Okay, this screencast is going to work with ionic compounds with polyatomic ions. Oops. Okay, so given the name of a polyatomic ion, you should be able to write its formula. This means that you need to memorize the polyatomic ion's name and their formula. Given the formula of a polyatomic ion, you should be able to write its name. You need to memorize that. There's a list that's about in the middle of the screencast, right? So once we've memorized these polyatomic ions, then we can use them to name ionic compounds that contain one of them. So if we're given the name of an ionic compound that has a polyatomic ion in it, we should be able to write its formula. If we have the formula of an ionic compound with a polyatomic ion, we should be able to write its name. So you may be wondering what a polyatomic ion is. Well, a polyatomic ion is an ion that contains more than one atom, hence the word poly, meaning many. So many atoms in this ion. An example is SO4 with a -2. This means that this entire quantity, this one sulfur atom bonded to these 4 oxygen atoms, has an overall charge of -2. Okay, this is the sulfate ion. This is the hydroxide ion. And again, this means there's one oxygen atom bonded with a hydrogen atom. Overall, this has a charge of -1. There is one positive polyatomic ion that you need to know, and it has the formula NH4. It has a +1 charge. Charge is also something part of that memorization that needs to happen. This is the ammonium ion. Okay. So how do we identify if a compound contains a polyatomic ion? Typically, it has one metal and 2 or more nonmetals, right? 2 or more nonmetals like these, right? Remember, your metals are your cations. So sometimes we will have a compound that just starts with the ammonium ion, NH4. You need to recognize this as being a polyatomic ion and be able to say, oh wait, that's going to be an ionic compound consisting of cations and anions in a crystalline structure. Another hint that we have a compound with a polyatomic ion is its name does not end with an IDE. There is 1 or 2 that does, with the example being hydroxide. This does end in an IDE and it is still a polyatomic, but most have an ending that's either like an ate or an ite, ITE, ATE. Here is the list of polyatomics that you need to memorize. We have the ammonium ion, NH4 with a +1 charge, carbonate, CO3 with a -2. HCO3 with a -1 charge is known as a hydrogen carbonate ion or a bicarbonate ion. Nitrite, NO2 with a -1, is called the nitrite ion. NO3 with a -1 is a nitrate. Phosphate ion has a formula PO4 -3. Phosphite is PO3 with a -3. Here's that hydroxide, OH -1, cyanide, CN -1, acetate, C2H3O2 -1. Sometimes you will see this written as a CH3COO-. This is how your organic chemist would write it. This is an inorganic chemist. For the most part, we're studying inorganic. This is usually how you'll see it written in this class. Sulfite ion, SO3 -2, sulfate, SO4 -2. Given the name, you should be able to give me the formula and the charge, because the charge is actually very, very important. Given the formula with the charge, you should be able to give me the name. So, how do we name these? 1, hopefully you'll recognize, hey, wait, that's a polyatomic that I just learned about. Ca I know is calcium, that's a metal. A metal and a polyatomic, oh, this is a ionic compound. We're going to name it using the name of the metal and just the name of the polyatomic ion. So that's calcium sulfate. Again, here we have a metal. Here we have something you're hopefully going to be shortly recognizing as a polyatomic ion. Na we know is sodium ion, and then it is the hydroxide polyatomic ion. Ooh, here's one where I don't have a metal, but I know that that's the ammonium ion, and it is bonded with the hydroxide ion, again, in that crystalline structure alternating positive negative charges. Aluminum with the nitrate, aluminum nitrate. I was naming just the polyatomic, that is an R, nitrate, Nitrate. Oh, here I have iron. Iron, wait, that's a transition metal. When we name them, I need some kind of Roman numeral to tell me what its charge is. Well, I know this is the phosphate ion. I have one phosphate ion. Its charge is a -3, so this has a total -3 on the negative side. That's a +3 then to make it neutral. I only have one iron, so that iron must have a +3 charge. So it's iron 3 phosphate. Okay. How do we write formulas then? Well, we use the same procedures as we did for other ionic compounds. I have calcium. I know that calcium forms a +2 ion. Sulfate is a sulfate -2. So this was a CaSO4. Iron 3 sulfate. Iron, this tells me it's a +3. Sulfate, again, is SO4 -2. To make this neutral, I'm going to need 2 iron, 3 ions, and I'm going to need 3 sulfate ions. Hopefully this struck you as looking funny. Okay, if we write it like this, it looks like it's 1 S and 43 oxygen. That's pretty absurd. What we need to do is use parentheses so that this tells me I need 3 of these polyatomics. Indicates that this is a group that forms the anion, and I need 3 of these anions to make this a neutral ionic compound. Okay. That ends the screencast.